Hi everyone, in this video I'm using the PhET friction simulation to explore how friction creates heat. Right now I've got two books stacked on top of each other, sitting on a surface with a thermometer on the side so we can track the temperature, and we've got a microscopic view of what's going on right here in this section between the two books. I will start by sliding the top book slowly left and right. Notice how almost nothing happens. The temperature barely increases. That's because friction is low when the motion is gentle. But now, watch what happens when I move it faster, back and forth rapidly. Notice how the thermometer started rising. That means friction is resisting the motion and converting my mechanical energy, the movements, into thermal energy or heat. So you might be asking, what exactly is friction? Friction is a force that always opposes motion between two surfaces. Even if things look smooth, like these two books, at the microscopic level, they're actually rough. Little bumps on each surface catch on each other. So you could say they're never touching each other. And so there are two main types of friction: static friction, which keeps objects from moving in the first place, and kinetic friction, which acts when objects are already sliding. When I move the book slowly, static friction barely produces any heat. But when I move it quickly, kinetic friction takes over and creates a lot more heat. You could say that it becomes more dominant. We can even describe friction with an equation, and you might already know it. F equal mu times N. Mu is the coefficient of friction, basically how rough the surfaces are, and N is the normal force, which depends on how heavy the object is. Heavier objects press harder on the surface, so they experience more friction. And since friction works over a distance, the heat produced can be estimated by Q equal F times the distance. The more I drag and the harder I drag, the more heat is generated. Also, if you look at the molecules in the simulation, you will see that as the temperature increases, and you probably noticed that when you move them faster, at the microscopic level, those molecules, they spread out. They thinned out and they spread out. They became fewer and they spread out. That represents the microscopic particles vibrating faster and moving apart as heat builds up. Kind of like how atoms in hot objects start shaking more. So to summarize, when I slide the book slowly, friction is low and barely any heat is produced. But when I slide it quickly, friction increases, temperature rises, and molecular motion becomes more intense. This is the same reason your hands warm up when you rub them together, or why car brakes get hot when stopping. Thank you for watching.